Welcome back. In the previous video, we showed you how to tokenize your data and then to clean your data further by removing stop words. In this video, we are finally going to get to some of the beginning analysis steps. The first type of analysis we are going to look at is how to determine the most frequently occurring words. Let's start by creating a variable to store the most frequently occurring words. So we are going to create a variable, and I'm going to title it Frankenstein underscore tidy word count. Then I am going to assign this variable to our stop words removed, which, if you recall from the last video, I titled Frank underscore stop words removed. Add our pipe operator to show that we are going to do something else, and then use the count function to sort by word. This line of code is going to count up all of the words in our stop words removed variable. If you look at this, Frankenstein tidy word count now shows us all of the words left with the number of times they occur. Another thing we can do is view this and choose to only look at a certain number of words. So let's use the view function to look at our Frankenstein variable that we just made, but we're going to use our pipe operator and filter so that we are only looking at the words that occur greater than 50 times. Now you will see that we have a data set with 28 words all occurring more than 50 times. This is one of the first steps to analysis that we can use. Now, while it is useful to look at the most frequently occurring words, sometimes this data is not very good for comparisons. Instead, we want to maybe look at percentages, which are ratios that are much better for doing comparisons. So let's go back to our code and write some code to look at word frequencies as a percentage rather than just a single number. To start, we are going to need to create a variable that houses the total number of words in our novel. I'm going to call this variable Frank underscore total words to keep this variable name rather short. And then we are going to assign Frankenstein total words to a function called nrow. This function counts out the number of rows in a certain data set. For our purposes today, we are going to count the number of rows in our Frankenstein tidy variable. If we were to take a look at our Frankenstein tidy variable, you will remember that it is simply the tokenized version of our novel where each word of the novel gets its own row. So by counting up the total number of rows in this data set, we will actually be counting the total number of words in our novel. Running this line of code, Frankenstein total appears down here under values as opposed to data. We will see that it has been assigned a number, and this number is the total number of words in our novel. Next, we are going to use the mutate function. This function is extremely powerful and helpful because it allows you to add data to already existing data tables. So let's create a new data table. This one I am going to title Frank underscore percentages, and I'm going to assign it to our tidy word count. And then using the pipe operator, I'm going to use the mutate function. What we have right now is a new variable that has currently been assigned all of the data in tidy word count. If we were to only run line 43 of the code, Frank percentages would look exactly like Frankenstein tidy word count. Using this pipe operator and the mutate function, we are now going to add another set of data to our table so that Frank percentages will have an extra set of data that Frankenstein tidy word does not. In this mutate function, we are going to add a column that we will call PERC, or percentage, and we're going to say that equals n, our number, divided by the number of Frankenstein total words. So what this is saying is we're going to take the number of the word, how many times it occurs, we're going to divide it by the total number of words in the novel, and then we are going to multiply this by 100. Let's run this code and see what happens. Looking at frank percentages, we see the word life, we see the number of times the word life occurs within the novel, and then we see a column percentage. This is 0.153. Essentially what this means is that the word life occurs 0.1% of the time in the novel. The farther down we scroll, the less times a word appears, obviously the smaller the percentage of the novel it takes up. This percentage data is much better for comparisons because it has been what we call normalized. Next, we're going to look at vocabulary density. We want to look at how rich the author's vocabulary is, or how often the author uses the same number of words versus how often an author uses new words. Does the author like to repeat the same words and phrases over and over, or does the author have a rich vocabulary where he or she uses new phrases and new words frequently? To do this, we are going to be nesting a few different functions together. We could also divide each of these into their own individual tasks, assign them variables, and then perform functions to create new variables. But nesting functions makes this process quite a bit easier. Let's start by creating a new variable, which we are going to call Frankenstein _ unique words. And we're going to assign that to the number of rows, and then we're going to nest the unique function, and then we're going to say Frankenstein tidy. Looking at this line of code, let's see what it does. It takes Frankenstein tidy, that data table, and it counts unique number of words. What this means is we don't want the word life, say, repeating every single time, so it's counting the number of words that are unique and not counting how many times they repeat. Then, once that's done, we're going to count the number of rows of that data, meaning we are essentially finding out how many unique words are in Frankenstein, the novel. Then we are going to assign that number to this variable, Frankenstein unique words. You will see that Frankenstein unique words is a much smaller number than the total number of words within Frankenstein. Now we can go to check the vocabulary density. Let's create a second variable titled Frankenstein _ vocab density, and then let's assign this to our unique words divided by our total number of words. This is going to give us our vocabulary density. If we run this line of code, we're going to get a number. Although looking at this number right now does not really give us a whole lot of information, if you are comparing two or more texts to each other, you can compare these vocabulary density numbers to find out which text has a higher vocab density and which text has a lower vocab density. Later on in this course, when we start working with corpuses of novels, we will be able to do the same thing with large groups of novels and not just one singular novel. Finally, in this video, we are also going to show you how to locate specific words within your text. One interesting thing you can do with just about any novel is look at gender and compare the number of times an author uses the word he to the number of times an author uses the word she. So, since we still have our Frankenstein tidy words object, which has all of the words of the novel before we removed the stop words, we can still use it. Let's create a variable where we count the number of times the author uses the word he. So we're going to call this Frankenstein _ he count. Then we're going to assign it to the length function. And then we're going to say the which function. And then Frankenstein _ tidy, double equal sign, quotation marks, and the word he. In this line of code, we are essentially counting up the number of times the word he appears within the Frankenstein novel. We can run this line of code and look at it, and it will give us a number here. We see that Mary Shelley uses the word he in this novel 608 times. Now let's do the exact same thing to see how many times Mary Shelley uses the word she. Running this line of code, we can see that the she count gives us 255 words, as opposed to the 608 for the word he. If we wanted to look at a ratio of the number of times he was used compared to she, we can write a line of code to do this as well. We can take our Frankenstein he count, divide it by our Frankenstein she count, Shift Enter will give us a number down here in our console, 2.38. So this tells us that Mary Shelley uses the word he about 2 times more frequently than the word she. All of these textual analysis tools are just scratching the surface of the things we will be able to do with our code in order to aid our analysis of single texts as well as corpuses of different works. Check back in the next video to learn how to make graphs of the data we are discovering.